Hello everyone, this is Elliot Rosenfeld. I'm a senior learning content developer on some civil infrastructure projects. I am filling in today for Eric Chappelle, the regular host of this series. Today's topic is a deep dive into a road rehabilitation workflows in Civil 3D for the 2018 Update 1 release. We have Chakri Gavin, a product manager for transportation, on the line with us today to give the presentation. I'm just going to run a few slides with you and then turn over things to Chakri.
Hey, before you start recording too, right?
I did start recording. Great. So if you haven't attended before, these product team webcasts we hold twice per month. Usually that's the first and third Wednesdays of the month. The goals are to inform you about civil product features from the perspective of the product teams. We want to give you a chance to ask questions and provide feedback during these sessions and bring the civil product users and makers closer together. Up next, Wednesday, November 29th, we have Scan to BIM for Infrastructure, which are point cloud workflows for InfraWorks and Civil 3D. That will be presented by Ramesh and David. You can find the registration announcement and link as you regularly get them in your email at the InfraWorks community site, on the InfraWorks forums, as well as social media. So at this moment, I'd like to just ask to take 30 seconds and enter some ideas for future topics you'd like to see into the questions window now. This should be your little GoToWebinar sidebar. Just if you have any thoughts of items you'd like to see in future webinars, throw those in the question panel now. Thank you. Also, I wanted to draw your attention to the new Autodesk Civil Engineering Community Center. This is civil-community.autodesk.com, where you can see news, the forum, galleries, tips and tricks on Civil and InfraWorks. You can find links to recordings of past webcasts like today's. You can find trending topics on social media, our idea station, product roadmaps, and learning content. Bookmark this and check it daily because we will be bringing you new content frequently. And just a last disclaimer, during this webcast and others, we may make statements regarding preview features or possibly planned or future development efforts. Just please note these are not a promise or a guarantee of future delivery of products, but reflect upon our current plans, which may change. And lastly, ask a lot of questions during today's session. We will see the transcript if we can't get to everyone's question during today's session, but we will also stop and make sure to address your questions and see if Chakri can speak to any of them today. With that, I'm going to turn things over to Chakri, and let me just change presenter and confirm I can see your screen. Awesome, I can see Civil 3D.
Okay, so just let me minimize my window here, and is there a way that I can, yep. So just let me switch to, can you guys hear me well?
Yep.
Okay, so just I want to run a few slides before I go into the product demonstration of using new road rehab workflow that we have done in 2018.1 for Civil 3D. Hi guys, I'm Chakri Gavin, Senior Product Manager at Autodesk. Transportation is my area of specialty within Autodesk products, both in InfraWorks and Civil 3D. And today we are going to look into what we have done in 2018.1 Civil 3D for an overlay optimization problem. Excuse me. So if you see the workflow today, like most of the tools that we have in the industry, you do for rehab projects, you do a lot of varieties of like data collection methods, both traditional survey as well as recap kind of thing, and you convert those data into a lightweight point data and line work, whichever way you captured your data, and you manually identification of the key baselines, right, for various aspects of your existing road infrastructure, and then you do camber correction or cross slope correction for each lane on the left and right sides. And most users actually at that point take the data into, at least on the highway side of it, they take the data into Excel spreadsheets and do, like check lane by lane how the lane slopes are, and how, the cross slope correction is making warping from station to station, because, like if you are correcting the slope from each station, depending on the slope tolerance values, like it keeps varying, right? So that makes it bumpy. Sometimes it is not safe, sometimes it is not pleasurable for ride-wise. So they keep adjusting lane to lane, and then they do a lot of, vertical adjustments for, how much minimum leveling I want to do, or maybe this area I want to do milling, so what's the minimum milling depth, and where this minimum milling depth, and do I have rutting, or do I have potholes or bump ups? All that kind of things they do, both in graphically as well as in a tabular manner, and final changes that they bring it into CAD. And then, last step, because of the adjustments that you have done so much, your design profile may be kinky now, right, just going up and down kind of thing, and you wanted to make it smooth. And once you adjust that, you wanted to redo the whole process. So this is a process typically most customers, like whichever tools that they have, have been using it, have been, like practicing in many different ways. A simplified version of the same thing, you're surveying the existing conditions and building surfaces and linear features out of that, and you're designing and redesigning traditional mill and overlays in your drawing system, and then you export them into multi-slope reports into spreadsheets, and you analyze lane by lane and all that kind of things. And then you review those reports, the errors, and and then additional optimization, and you make the adjustments that you have done externally into your CAD system, and you repeat the process. So that's generally, like the process that has been done in most of the tools. And in 2018.1, we looked into that, and we were working with some of the DOTs, and we felt that, while there are tools in all softwares, including Civil 3D, rehab sub-assemblies in the past, we felt that that isn't a user-friendly way of doing it. So our goal was to develop an interactive workflow while you are achieving this optimal, like solutions. And the point of doing it is not only the interactive workflow, but actually to rapidly develop your various alternatives to help save costs on rehab projects, and this reduced cost should help you do more miles. In the past, actually, a lot of agencies, because they can't go through this level of detail, they used to do, let's do 2 inches overlay, leveling and overlay, 2 inches of leveling and then overlay, or maybe 2 inches of milling as a standard contract, and do that. And these kind of things, like while you are doing the right things, but it is not going to sufficiently take your dollar value into sufficient number of miles rehabilitation projects. So if you save the cost on your by doing a prudent design, you can actually rehabilitate more miles, is the key selling point that we see most DOTs are focusing on now. And we also can identify with this process actually some sort of pavement existing patterns, and we can actually take the conversation back to the pavement managers and the traffic managers kind of thing, to see how the newly rehabilitated thing can increase its usage by better usage. It can increase its lifespan, so that the next rehab can actually be prolonged. So we made in the process actually very dynamic and iterative process, so that the various walks of the steps previously that I was showing here, all these things are connected. So you don't have any static reports, and you're not doing anything outside the CAD system and then manually bring it into the CAD system kind of thing. We tied everything that we can, and we wanted to continue to improve further. So that's where the new method is. The new method that I'm going to show in the next like a half an hour or so before we open up the questions contains 3 aspects of it. So you will see a very familiar multi-viewport system kind of thing as you are doing the rehab generation. Going away from traditional corridor building, we are offering a new experience to build corridor in context of existing conditions as you compose your subassemblies. But by the way, I'm not even going to start with a subassembly and an assembly, and I am expecting, I specify my intent through my rehab corridor parameters UI. I'm going to specify my intent, how I want to accomplish my rehab project. And these settings that I'm doing it on the right side is going to set, create a subassembly behind the scenes or use one of the stock subassemblies that I have and set it to these needs, its properties, and it is going to build me an assembly and applies that assembly to me to build this corridor. So in the past, if you are creating a corridor object, you are creating a corridor object, starting with an assembly, attach sub-assemblies that you want. You need to decide which assembly you want to use for based on what kind of conditions. So we took that away and we started focusing on the workflow rather. And having said that, that will build you an assembly behind the scenes to you that you need to apply. So next time when you come and change these properties here, it will recreate using different sub-assemblies if needed. In the same assembly, and it updates the corridor object. The third piece is the reports. So this is one of the critical aspects of improvement that we did into the workflow. Again, dynamic, connected. So as you finish your milling and leveling project, we come up in 2018.1 two reports, cross-slope correction report as we did, and milling and leveling report. Particularly cross-slope correction report will give you various statistics about at each station, what's the existing ground slope, what's the ideal slope you want, and what's the slope tolerance you have, and what's the difference, and then therefore based on the tolerance, did we correct any of that or not? And not only that, it gives you relative gradient line, which is the warping angle, like how ups and downs as you are driving, and what's the accepted, relative, that relative gradient. And did you violate the criteria? If you violated the criteria and adjusted, it shows a lot of things. I'm going to demonstrate them. So you can go and change the values. As you change the values, your cross-section output and therefore corridor object is going to make changes too. So that's in a nutshell how we tied all these things together. Like I said, we didn't even start with an assembly. And so the key aspects before I get into, so no need upfront assembly creation. Optimization goals are the ones that drive you, what assembly and how cross-sectional design has to be. And we have a special rehab contextual tab that lets you walk through station by station even before you create your corridor, and commit to that, and then see the conditions as well as applied conditions, how they are going to be. And you can review them as you are building station by station, and you can change the parameters for the entire region of rehab, or you can change it for just a station kind of thing. And all those things are dynamic, and and whatnot. After doing this, you can use this corridor like any corridor, and you can extend it for a rehab and widening projects, not only rehab, you can add a lane afterwards, you can add a shoulder, or whatever you wanted to do to make it as a rehab and reconstruction project kind of thing, or rehab and widening projects kind of thing. So let's get into, and also you can actually easily create the rehab reports. I will show the rehab reports and the heat maps of the data, so that where the deep milling is happening, or too much of overlay is happening across and along the road, and you can see the patterns. And this is where I was talking about, will give you what has happened in the past. An indication of these heat maps will give you, so that you can identify the areas of rutting and potholes and bump outs kind of thing. So with that, I'm jumping straight into the product now. Any questions so far?
Nope, things are good.
Yeah. Okay. So here, this is a project actually that that came with a traditional FBK file, Autodesk-based FBK file equivalent that I have taken one, and I imported that using survey workflows in Civil 3D, which created to me, a points and a point groups based on the description keys that I have, and also it created some feature lines of survey figures. I mean to say, survey figures based on the description keys that I specified in the import process. So all I have in this project is, let me just delete my corridor here, select that, and delete that. And I am also going to select an assembly that I have, and I delete that. So this project at this point is completely, like I said, like I have survey figures extracted out of that FBK file, and I have points, point groups, and I created a surface called, existing ground. Delete this. I have a surface called existing ground from figures. So one surface, and one of the survey figures that is center line CL survey figure, I used and I converted using Civil 3D best fit alignments. I converted into an alignment, and then I sampled for that alignment. I created a profile from existing ground surface. I don't have any finished grade profile. So just to show you what I have, this is my existing ground profile along that alignment that I created from the survey figure marked as the edge of center line from the survey data, and I created a best fit alignment. And that's the existing ground profile. That's all I have for the data. So I also created a sample line to show you how my section randomly, at a station 100 and I created, and it looks like an existing roadway, right? So this is the data that I have. And from this data, what I want to create is now a rehab corridor. So standard, go to corridor objects. There is a new command now in the product. If in the previously there is only one corridor command, you click and it will invoke corridor creation command. And the new rehab corridor command, we added in 2018.1. So you can see the dialog is very similar to the existing corridor. And the only difference between the existing corridor and this is now we are not asking the users to create, select any temp assembly. Everything else is same. What profile do you want to use? What's the alignment? What's the profile for that? And do you want to target to an existing surface? This is it here. And I'm going to make a smaller section not to go through the intersection area. Just right before the intersection, I'm going to complete the rehab. So I selected the end station, something 294. And so no assembly to say, right? So say OK. As soon as I hit OK, it's going to bring me a 3 viewport configuration. I can make it a 3 viewport or 4 viewports. Fourth one being maybe you wanted to show your slope elevation diagram or maybe a model. So this environment, these settings are sorry. So let me zoom into the area where we are going to focus building our rehab corridor. And if I zoom out here, so you can see that this is the area where my existing ground, because we haven't created any corridor yet. So on the prospector, you can notice now, there is a corridor object, dummy empty corridor object created. And it also created a new assembly, assembly 8. And right now, you can see that, it has, it automatically brought in a overlay level crown subassembly to me. Why? Because out of the default, if you can see on my properties on the right side, rehab parameters, I'm actually looking at a level only vertical adjustment with 1 lane on the left and 1 lane on the right. So I can actually increase the number of lanes here. That automatically makes my subassembly change on the fly for you. So I'm going to stick to, because looking at the data, this data seems to be 1 lane on the left and 1 lane on the right. My stationing is going from north to south. Therefore, this is my left, and this is my right. On the left side is my right of alignment. So I'm going to use 1 lane, 1 lane. So, by the way, if I change my, my conditions to level only to mill only, you can see that my prospector flickered. And now you see that the assembly is actually looking for a subassembly called overlay mill count rather than level count, right? So I'll start with level only for now. And what I'm going to do is, since I can specify my my design edge of lane width as 12 feet as fixed feet, or I have a survey figure for that, right? On my left side, I have edge of pavement on the east, and I have an edge of pavement for the west. Two survey figures I have. I'm going to target them here. So I can do that right here, and selecting it, just like the targeting that you do in Civil 3D. I selected for left, and I'm also going to select for my right side here. Just I'm navigating through my lanes, or I can drop down and I can select this. So because I said 2 lanes, one left lane and one right lane, right? That's why this combo box has only 2, LL1 for left lane 1, RL1 for right lane 1. And I'm going to set the target even for that. Lane width target, and select now this survey figure. That survey figure I selected, and say, okay, this one is the edge of pavement on the west. So I selected that. And now if you see, by the way, I just wanted to mention you something here. Sometimes your existing edge of pavements may not be the same as your finished grade edge of pavements you wanted to be. Maybe your existing edge of pavements are crooked, therefore sampling existing slopes from your center line to the existing edge of, fixed with the existing edge of pavements, or even the existing edge of pavement survey figure may be inaccurate. So you wanted to offset that existing edges inside, and you wanted to deviate. Or if they are crooked, maybe you wanted to have a fixed with the existing finished grade design edges. Or maybe you wanted to design your finished grade edges and rehook them up, right? So to do that, we have a control here. This is questioning, are your design lane widths are same as existing lane widths? You can set no. By setting it no, you're actually enabling, okay, select a inside edge of lanes now information. You can either same thing, either give the system a fixed values, or you can both inside edge of existing lane or outside edge of existing lane. If you have a feature lines or alignments or a polylines, anything, you can target them. Same thing exactly, right? All this information that you are providing will be passed into your set of assemblies and sub-assemblies behind the scenes, and will set your conditions well. So, up front, we are taking away a lot of those, the complicated UI that you are, like otherwise you have to do into this process. So I said for now, it is same. Now I'm coming back to the bottom section. The bottom, so the top section is primarily to configure your lanes. Right, so how many number of lanes you have, and where their edges are, inside edge and outside edge, or maybe their widths, so on and so forth. This is it. The bottom one is the one that is actually going to do the real, optimization constraints. So there are 2 optimization constraints you are looking into. One is a cross slope correction. The second one is how you want to adjust your finished profile up and down. Do you want to do mill type, or you want to do level type, or you want to do sometimes mill and level? Or so far we covered that, and we have for future releases we have a little more than what I have right now here. But for now, that's exactly the 2 categorizations. In cross slope corrections, if your ideal cross slope is 2%, let's say, which is where I specified here. And if your existing ground happened to be 1.8 or maybe 1.3%, so too flat, right? Whereas you wanted to have ideal cross slope as 2%. So the difference is, if you are holding this exactly the same profile point, you are actually going into a milling condition, even though you didn't ask for a milling kind of thing, right? So at the center line, no milling, but as you go to the edge of pavement, you are going to deeper and deeper milling. So maybe you don't want to have too much of a milling, right? You want to say, okay, I want to give a cross slope tolerance of 0.5 value, which is what you specify here. and therefore do an optimization for the cost slope based on that. So in this case, because you have an existing ground at 1.3 and your ideal is 2, so the difference is 0.7. So you're going to lift your or lift up or compensate your design slope from 2.0 to 1.8. Now the difference between 1.8 and 1.3 is 0.5. You're within the tolerance now. So whenever you violate the tolerance value that you give here, is what the computer, like the Civil 3D process will adjust, to that particular tolerance value. I'm just making it to be 0.2 for this exercise, slope tolerance. And the next two are actually design checks. You can actually specify lane break slope. This is more useful if you have 2 lanes on the left, 2 lanes on the right, and if you are adjusting each lane for cross slope checks, and is the lane break is acceptable or not, you can actually put a flag there. And the relative gradient is the slope changes from station to station for a given lane, and what is that limit you want to show. Now I'm going to leave that as a 0.2. So I'm going to do the level only, and minimum level depth I want to put something like 0.15. Feet, and overlay depth is 3 feet I'm going to use, and I'm going to hit apply, right? So the moment I hit apply, see now it actually, your corridor on the prospector on the left side, if you see, it's not out of date anymore, and your assembly is overlay level crown. Now you can see in your CSV kind of environment now, and you have a special rehab ribbon also on the top. So we can navigate from station to station here, and so it shows the values, like for the rehab values, we'll get into that. And also you have a station list of stations here you can jump directly to. And I was talking about the viewport configuration. If you want to change the 4 viewports, 3 viewports, and all that, you can configure very similar to the CSV in the roadway modeling. And you can show display objects if you have a pipe and other things, just like CSV in the past. You can show the underground pipes and all kind of thing, and you can use the inquiry commands to investigate between your, milled surfaces and so on and so forth. What is the cover depths for those utilities and so on and so forth. These are standard functions that you expect to see in a CSV environment, right? So the difference is here. You can add a new corridor region here. New region for rehab. You can navigate the station by station, and there is something called, if by mistake, if you close the rehab parameters, you can invoke that using clicking this button. And there is a new one, Rehab Manager. I'm going to talk in a few minutes from now. So this is another button, very useful, right? And if you see in the profile view, we're actually tracking the station value 50. At 50, what is the existing ground elevation? What's the design profile elevation? By the way, I didn't start with any design profile, right? So therefore, EG and FG are same here. I chose EG profile as an FG, my initial profile. Therefore, they match. And then what is the adjusted elevation value at the center line? So it reports to you for each station. So as you navigate station to station, the tracker keeps changing and the values getting updated. And the tracker also is there on the plan also, like you can see that. That's a tracker here on the along the plan, even though there is not much data we give right now. In the section view now, so this is a critical lot of information here. We mark where the critical point for analyzing the level only. So if you see at an offset 0.18 is where exactly that 1.8 inches, which is 0.15 feet, is applied. So it scans through on the left side of the pavement as well as right side of the pavement and finds out the highest point for across the cross section. And that highest point is what it selects as a leveling condition, because that is where the minimum level, everywhere else the leveling will be higher than that. So that's the critical point that you wanted to provide, that minimum level constraint that you specified to be. That's the minimum level here. This is the point. By the way, because this point, so yeah, that's the point here. And it gives you the values at all other critical locations also. and it gives you the slope, what is the slope that is applied. So obviously it looks like that there is no slope change from the ideal here. It is within the tolerance, right? So that's what it is. So you have a level surface and you have an overlay link and a level link here, showing leveling depth of 0.15 and the overlay depth of 0.3. So any questions so far?
Yeah, there's a couple of questions on the line. One question about the cross-section viewer is what's the information that's contained in the warning glyph?
That's a good question, yeah. So if you hold on the warning glyph, so you said that, I remember that I mentioned we have two lane break slope limit as well as relative gradient limit. So whenever it is violating that, so the lane break slope here is not really a violation here because I'm looking at left to right, right? So I think we generalized for any lane. I think we should have filtered at the crown, but because I specified the lane break slope of 0.5, this may be more meaningful in an adjacent lanes of the same side rather than around the crown. So this works good for divided roads as well as undivided multi-lanes case. So similarly, like a maximum lane break slope, that's what it is listing. So we specified maximum lane break slope as 0.5, but the real slope between these two lanes is 4.0. That's what it is saying. So any other slope, probably in a next example that I'm going to show, it lists more things.
Great. Yeah, a couple more questions here. So backing up, when you start building the rehab corridor, I just wanted to confirm, someone is asking, does the rehab corridor creation apply to the cross sections? Does it apply the rehab parameters to these cross sections?
Exactly. At this point, this has no different from any existing any corridor object. If I close this and select that particular corridor, go to my existing corridor cross-section view or cross-sections, if I plot, these parameters are applied at that, and you can see in that CSV or in assembly properties or whichever way you are existing in the current procedure you are working on, same things apply, and all this information is applied to that particular section by section corridor also.
Great, thanks for confirming that. Okay, so 2 or 3 quick more questions here. Can you select multiple survey figures if the figures are broken up in multiple segments? And another?
Absolutely.
Okay.
Absolutely. This is, again, like in existing corridor models, that you can, in that target thing, like if I go here, I'm looking into the right lane is on my left side. I can select multiple, if your existing edge of pavement on the right side has broken feature lines, and if you organize them by a layer, all of them are on a specific layer, you can go and choose them by layer. So this functionality is there in Civil 3D for corridors for long, and you can continue to use that. So, yep, you can have multiple of them, and it doesn't have to be contiguously, like one after another with a gap. Sometimes you may have overlapping of them, and even that works because Civil 3D has worked, I think 5-6 years back, this particular feature, maybe 8 years back. We added that even if they are overlapping areas, we take the nearest, see the control at the bottom. Do you want it to the nearest offset or farthest offset, right? You can choose what rule to an extent, right? If you wanted to jump sometimes nearest, sometimes farthest, and interactively we don't. But in generally, if you can follow a rule, you can actually do that too.
Great. And another related question, can you use polylines or feature lines instead of survey?
Same. Exactly. For the targets, right?
Yes.
Yeah. So again, that's same thing, right? You can use the feature line, survey figures, and polylines.
Yep.
Or you can use alignments. This is once again an existing Civil 3D functionality.
Great, Shiva. Great. Okay, a couple more questions, and then we should let you get into the Rehab Manager. A question here was asking for clarification on terminology. What's the difference between the mill, the overlay, and the level?
Okay, so mill is something, mill and level are two different operations. In one of them is, so if I go into let me zoom in here. So I'm doing level. So my existing ground is the bottom layer here. If you see, if I go onto one of the edges here, you can see that my existing ground is the bottommost link, right? So this is my existing ground. So in a level, what we are doing is first we are trying to find some sort of regulatory material. It doesn't have to be an asphalt, right? You're primarily what you're doing is you're filling in a material to the level before you put the final concrete or an asphalt kind of thing. Sometimes it could be the same material as an asphalt or a concrete kind of thing. But traditionally in many highways we do a regulatory material of some sort of semi-binding material here, and then top pavement will be added as an overlay. So some people can put, some projects will have both level material and overlay material as same, but the milling is a separate operation, right? Milling is you're stripping out your existing pavement to a certain depth, and then you are putting an overlay or a level and an overlay. So that's the difference between those two, level and mill. And overlay is something, traditionally, top courseware is what you're going to put on top of level layer.
Great, thank you. So how would you use a mill and overlay to match the existing ground?
To match the existing ground?
Yep.
Crown or ground?
Ground, sorry, ground.
Yeah, so to match the existing ground, the same process actually, like if I use here, basically first you are doing a milling operation, and once you do the milling operation, your level is now completely parallel to the, bottom of the mill. So if I go here now, I can, that's the whole point of this workflow, right? So all I have to do is, now you can see that my subassembly changed here to overlay mill, level, and crown, and my corridor is out of date. And the moment I hit my like apply button, so you see that I chose minimum mill depth as a 0.0. So basically I wanted to look for the lowest point on the existing pavement, right? So lowest point on my existing pavement, I think that condition happened here. And from here I create using the cross slope that we calculated, right? 2%. So we apply a 2% towards the crown from here, right? And now the mill surface and level surface are now parallel to each other, because level now is off of mill surface, and we specified a depth of 0.15, so it is going to be parallel to that. So mill is a condition now is going to look for where is the critical mill. So obviously now if I go back to my center line, because my outside lane, left outside edge of the lane is the lowest point on the surface, for which the cross slope point of view, my minimum milling condition is met. So therefore, look at that. It looks like approximately some sort of 0.05 inches of milling we are doing in the middle here now. As you go out, so I can see that how much milling is happening on this edge. So mill depth is almost 0.25 inches of mill depth is happening on the right side. So the parallelness will come now between the mill and this one level. And again, level to overlay is always going to be parallel in this case.
Great. I think we have time for two more quick questions before we let you move on. One question is asking, how can we perform this workflow for dual carriageways, median separated roads?
Yes. So actually I do have an example that I want to show that. So before going that, because I have an example drawing, before go to that, so I'll briefly touch where it is. So first and foremost, if you have a dual carriageway, but one lane on the left and one lane on the right, you keep lanes 1 and 1 here. But now what you're going to do is you're going to either assign your inside edge of lane for the left and right sides, depending on the lane property you chose. Either you give a fixed value or assign a target for that. So that indicates obviously that this is a divided roadway case, right? So the controls are here. set number of lanes that you have on the left and right sides. If you have a divided dual carriageway, select this inside edge of lane offset for right and left lanes. If they are fixed value, enter the fixed value. If they are not, choose each one of them inside edge of travelways target here. Just the way we choose outside edge and lane width target, we choose the same way you do that. Right, so I'm going to show one of the example projects I'm working on for this, that illustrates this model. Okay, any other question before I move to Rehab Manager?
There was a related question is, how would you do a rehab project in conjunction with road widening?
Yeah, so that I'm going to show right after the Rehab Manager.
Great.
Live. Okay, so that I'm going to show here. So now, first let me show the Rehab Manager. I go to the Rehab Manager here. So you see that this is just a, some of those panorama windows that we have in the product many places. And this one shows me that cost slope report is this, and I'm going to expand this size a little bit for now. And so it shows actually which stations this tolerance is, like I specify the tolerance as 0.2 purposefully very low, so that any little subtle differences come, and it is going to as I click that, first thing that I want to show you is notice that cross section is updating and your profile view tracker changes, your plan tracker changes. So it is completely dynamic at this point. So see that here at the station 150, station 150, see the station list changed on the top two. And the tolerance is 0.2, but the difference is 0.26, therefore it adjusted. Relative gradient is still within the limits, and otherwise it would have flagged with a red color there too. And the corrected slope is 2.6. I thought that let's not make it to 2.6. I want to change back to 2 at this class, at this one. So I can go ahead and make change to 2.0. Right, so the moment I change that to 2.0, you see that my cross section, first of all, my previously it was 2.6 slope, and now it changed back to 2.0, and I'm actually changing the left side, right? Sorry, right lane. I changed right lane, so left lane I turned off. By the way, I can actually, if I have so many number of lanes, if I want to investigate lane by lane, I can toggle on here and toggle off. And do that. So I want to see the left lane. I change the left lane to 2.05. Let's say I'll make change to 2.05, and the moment I change that, your cross section already changed to represent to 2.05. And also you can see I'm clicking away somewhere else. You can see that wherever user changed, those colors will change to green, indicating that, hey, by design it should have been 2.06 and you changed it to 2.05, so kind of visual indication, right? So two things: one, it is interactive; two, it has a visual cues to indicate where the criteria is violated and therefore where we corrected it and where user has manually overridden. So those are the changes that we have here, right? So that's one. The second thing that I want to show is a milling and leveling report. So milling and leveling report has two aspects. One, incremental milling and leveling report, which is at the center. So you can see that starting from 0, -5, -10, 15, 20, and so is the case on the right side and left side, right? And it gives you, this is the heat map that I was talking about, how the milling and the leveling is as you progress from station to station. Again, so it's interactive with your cross section above, and you can jump directly and take a look into that. So this gives you an idea of where we are doing mill and level, right? Yeah, so mill and level, therefore I'm giving the milling. Leveling is flat, uniform above the mill surface. So this is a report of mill and level. So you can see where the level, maximum milling is happening, and the pattern, series of stations and series of offsets it's happening. If you want to increase the offset, I'm going to make it 4 to anything, like just like 5. So sorry, 5 to 4 if I change, and so it changes the offset values. Now it reports from 0, -4, -8. So you can keep increasing the offset value here. The second aspect of milling and leveling report is edge points at every critical point. So what is a control point? Control point is the one that actually specifies which point along the cross section in each station, at each station, is actually controlling whether it is for mill or level depths, right? Or either high point or low point. It lists that, and also it gives you every edge point. We only have one lane each side, so therefore you have lane edge one and edge 2 points. If you have 2 lanes, you will see three edge points. So that's so on and so forth, like it on the right and left side. So that's the milling and leveling report. You can change your settings for the milling and leveling, hitting this the gear button. So you can see, you can change this, what is the maximum relative gradient value, which actually syncs to what you see in the rehab parameters, and the maximum lane break value, and what columns do you want to see in your report, and also for your cut, milling and leveling ranges, like how many ranges do you want to see, and things like that. So it's more of a settings here, and based on that, it if I refresh, it's already refreshed dynamically. And next one, you can export this to an external sheet. So I'm going to call it as to call XML file, and that XML file gets opened in a in your sorry, I haven't set my. So that's the report. So you can have your own style sheets to customize. We have a out-of-the-box style sheet customized to show it this way. You can take it into any spreadsheet or anywhere else. All this information, the customized values of 0, -4, right? Exactly the way that you saw. And this is for mill and level, right? So let me create another one, same way, cross slope report if you wanted to analyze. And so to cross slope, if I do that, and oops, where did I do to cross slope? So that's a cross slope report value. So if you wanted to still do some statistical analysis on this and create, in Excel-based curves for each lane grade slopes kind of thing, and if you wanted to, any analysis, you can still take it into a spreadsheet and do what you wanted to do. So that's the report manager. Now coming back to any questions before I go to how to widen this now?
Yes, a couple of quick questions here. Several people are asking about the concept of cut and fill depths. Is there any settings or ways to assign maximum or minimum cut and fill?
So you wanted to limit how much vertical shift you wanted to do, or so mill depth, minimum milling depth is so you are looking into maximum mill depth, I'm assuming. Is that right?
The questions on the line are for a minimum fill depth and a maximum cut depth.
Yeah. So that's what I call, maximum milling, and also we have minimum leveling and also maximum leveling. So you don't want to elevate too high and all. This is something that we are working on for the future. Right now, we don't have the limit of how much maximum you can mill, and similarly, like how much, leveling should be constrained also. Those are the two things that we are working on at the moment.
Great.
So you can add this functionality. These subassemblies that we created are .NET subassemblies. At the moment, you can go and make changes to the .NET subassemblies to constrain them. That's out of the box. We don't have that yet. It is possible to do because at the end of the day, these are all same as subassemblies actually. So.
Great. And another related question, is there a way to keep the outer edges in place? So basically mill and level within a curb section while keeping the curb and generate a proposed centerline profile?
You want to, I'm sorry, do you want to keep the existing curves or you want to replace the existing curves also?
keep the existing curbs while milling and leveling within the curb section and generate a proposed center line.
So this is what I did is, so this is exactly the same thing, right? Like I have a curb section here and then a sidewalk in this example. So I took inside edge of that curb to inside edge of the curb, and I did a best fit alignment here. I could have choose the best fit alignment many ways, but I chose the existing CP. But the profile now I can smoothen it. Like one of the reports that I was showing, I can actually get the the profile off of this process and create a design profile out of this particular corridor, and I can use the existing best fit profile tools on that object to smoothen it up. So that way you are actually getting a best fit alignment and a best fit profile. That's one way to do that.
Awesome. Yeah, those are the questions. Great, thanks.
Yeah. So I'm going to zoom to the assembly that it created, right? So one of the question is, how do I do? So at this point, this corridor has no difference between any Civil 3D regular corridors. It is how I say is, this is a 100% Civil 3D corridor, plus it has a special functionality. It doesn't have any restrictions that you can't do with this one with your corridor object. So all I'm going to do is, I'm going to go ahead and go to, let's say I'm going to add a shoulder here, or I can add a lane, I can add a new lane here. And I'm adding the lane on the right side, right? So lane outside super AOR, I want to pick that lane and attach to this, right? So, and Civil 3D sub-assemblies have a good tool that if you wanted to have this lane to follow the slope of your rehab slope, I can go into assembly properties and go to the construction tab. This is, Civil 3D corridor objects. Since its beginning, it has this functionality. As far as I can say, 2005 release also has this, or 2006 release. So if I go here, and default slope is 2%, but I wanted to get the slope overridden, and I can go and say override that with overlay mill and level crown left side. We are on the left side or right side? Oh yeah, right side slope, because I'm adding on the right side, right corrected cross slope, because I wanted to use the corrected cross slope, right? So corrected cross slope, and say okay, it automatically picks up that particular thing. All I have to do here now is I'm going to close that and rebuild my corridor. If I had set my automatic rebuild, you could have seen that. See, look at that. The slope is 2.15. Therefore, it automatically applies the slope of 2.15, and it just keeps following this particular lane at this point. So, and you can choose any other way also. If you have slope elevation, you can actually, your ideal cross slope can be set to right here on the rehab parameters. I don't have slope elevation specified in this alignment, but if you wanted to use slope elevation, use slope elevation. Say yes, and it will look for the slope elevation table on the alignment. And yeah, that's one, right? So if you have multi-lane, so let me close this first. Let me close this and open another drawing. Say no, and I'm gonna open this drawing here. So this drawing is a different kind of input data from. So for this project, I used Civil InfraWorks. You guys, some of you guys may know it already that in InfraWorks we have a nice, cool recap feature, and from the recap you can actually extract corridor surfaces and linear extraction of features. So I used InfraWorks recap functionality to get the surface that you are seeing here, and also to get the linear extracted features from the corridor, along that particular corridor. So there is if I go to shape, import, export, I think show geometry, breaklines, monitor, property data, display property. So this is a new tool that is, I'm going to hide something people who are on the, on the sandbox and test build kind of thing probably are aware. This is a tool that we have been working working for a long time. So anyway, so the bottom line is these are imported from shape files. So you can use Map3D shape import files from InfraWorks to bring the data into Civil 3D, and that's how this data is brought in. So obviously you can see it's on a highway project with an interchange here, and you can see my existing cross section looks like this, right? So this white line is my existing cross section, and therefore it's a divided with a median depressed divided road. Seems to be like two crowned road on the both left and right sides kind of thing. So this project is exactly as one of the questions that was raised. So I selected this project, and again on the corridor contextual tab, we added a new command here. If you notice, edit Rehab Carter. So this is a new button, and this button shows up only if the corridor happens to be a Rehab Carter. I selected that, and it's asking me to pick a region. I only have one region. So I select that one region. I will briefly investigate how I worked on this project. Same thing, when you try to edit, you can see that this is the one that we median depressed with the dual crown corridor object, right? So here what I did is so you can see that I set two number of lanes, right? And the moment I set the two number of lanes, and I also specified, is it it identifies it automatically based on the structure there. So I specified for each lane, inside edge and outside edge. You see that feature 5 and feature 2 for left lane 2. This one on the left side, and the left inside is LL1. And LL1 I gave feature 1 and feature 5. So so that's how I specified feature 5, feature 2, and then LL. So feature 1, feature 5, feature 3, feature 6, feature 6, feature 4. So 4 targets that I specified to indicate how the structure is. That's how I controlled it. And then I also said that all lanes use the same cross slope. If they are not, I can actually set no here, right? I can set no, and then I can specify right lane 2 with a different slope compared to right lane 1. It's my choice. Usually that thing happens if you have a single crowned parabolic cross sections, inside lane to be flatter than the outermost lane on the right side kind of thing, right? Your lanes may go from 2 to 2.5. The lanes in between will change, 2.2, 2.4, 2.5, something like that. So parabolic cross sections, you can use this, not all lanes don't use the same thing. So the moment I say no, you can see that each lane slope is invoked here, and you can start editing it here for lane by lane slope now. That I'm setting it yes, so that's what I did here. Yeah, so when I go to the Rehab Manager for this now, obviously it should indicate to me, so I'm waiting for that. So it should indicate to me that Rehab Manager, actually this is a long corridor that I have very tessellated sample points on the through the recap. So I haven't pruned. So it is going to indicate to you if I go to the mill and level report. Okay, so I come here. So this is a leveling example. Therefore, I see the colors here. So it's gonna give. So you can see that in the middle there is no report because we haven't done any. Rehab here, right? So even your inside edge is varying actually on the left. Sometimes it's minus 25. Sometimes it is at minus 20. So you can see that clearly where your median edges are ending and moving kind of thing here.
Great.
That's
So we have about a minute left until it's 1 o'clock. There's a couple more questions. I'm not sure if we're going to have time to get through them all, but I'm just going to see if you have time to answer one. Is there a way to use an existing outside edge of sidewalk, say along existing buildings, to work inward to a centerline profile?
I'm sorry, can you repeat that?
So the question is saying in urban roadway rehab, building landings and doors cannot be changed. So can the sidewalk slope and curb height be used to control roadway elevation as you move toward the center line?
Yeah, so that's a, I said that one of the things that we are considering for few right now at the moment now. So the point is we do horizontally hook to those points, but from the elevation standpoint of view, to hook them or to constrain specific points at the moment, that needs to be done through the subassembly. So you can take this subassembly and we can augment that to do that, but in the workflow, in the UI-driven workflow, it's not done that yet.
Great. So it is 1 o'clock. You have answered 90% of the questions on the line. That was a great session. I wanted to just remind everyone that up next week, or I'm sorry, November 29th, we have a webcast focused on point cloud workflows for InfraWorks and Civil 3D. Also, the recording of today's session will be posted to the Civil Community website as soon as possible, ideally today, but it may take a few days. Thank you so much for tuning in. Thank you, Chakri, for presenting today, and have a great day, everyone.
Thank you, guys. Thank you all.